So the section B, you will have two sections in your examination hall, section A and section B, as per the NTA notification given. Section B have 15 questions. We'll have 15 questions, and out of which you have to choose the maximum 10 questions, as I told earlier in the starting of this video. This section B will based on the complete syllabi, that is reduced syllabi along with deleted topics. But on the prediction, on the basis of prediction, I have selected here 5 questions in this sample mock paper from deleted topics. Let's start the section B with the first questions. Two identical rods A and C, two different metal having thermal conductivities in the ratio 2:3 are kept in contact with each other at C 100 B, and then you have to find out the junction C. The temperature, we have to find out the junction C. It is also based on the deleted topic of the CBSE, announced by CBSE board, last 2-3 months ago, and we have to find out here the junction temperature. From the KCL, Kirchhoff's current law, we can get here thermal current I1 and the thermal current I2. Then the sum of this thermal current I1 plus I2 at the junction equal to 0 as per the Kirchhoff current law. And I1, I2 are the thermal current. Thermal current means the amount of heat energy flowing per second. It is known as thermal current. And thermal current is equal to, similar to the potential difference. Here you have to write the temperature difference, that is 100 minus theta n by thermal resistance 1 plus 25 minus theta n by thermal resistance R2 equal to 0. Now we have to check the dimension. Two different materials having thermal conductivities 2:1 kept in contact, that is two identical rods. Their length and cross sections are equal. The thermal resistance, I must say it is R equal to 1 by K L by A, and L by A is same for both the rod. That is both the rod contacting at a point C. We have to find out the temperature at the point C. Here, so since L by A are common for both the rod, we can write here it is K 100 minus theta n plus K 220 minus theta n equal to 0, and it is 200 minus theta n plus 325 minus theta n equal to 0. 5 theta n 5 theta n is equal to 200, and it is 75, so 275, and theta n equal to 5 degrees centigrade. Okay, and the right option here is 4. Next problem. The question is selected from the deleted topics. Okay, next problem. A moving charge produces electric field only, magnetic field only, both of them unidentified. It is not true. It is not true. Electric field charge can produce both electric field and magnetic field. Charge always produces electric field around it, and charge also can produce magnetic field around it. So moving charge produces magnetic field around it. So we must choose here the both of them. Okay, next problem. A motor car blowing a horn of frequency 194 vibrations second moves with a velocity 70 km/h towards tall wall. The frequency of reflected sound heard by the driver will be. It is also based on the deleted topic. It is the topic from Doppler effect. Driver with a car moving. It is wall and frequency n prime, it is actually acts as a virtual source, virtual listener, it is virtual listener, and frequency, that is source moving towards virtual listener, listeners, V by V minus Vs, source moving towards stationary listener. Okay, and after reflection the frequency is n prime, but here driver of the car received this reflected wave, that is n prime, but here driver of the car is the listener this time. So the frequency received by the driver, it is the, this become the virtual source of sound after reflection, virtual source. The same wall can be considered a virtual source after reflection of the wave. So driver is the listener here, so it is frequency n prime V driver, that is listener, moving towards virtual source. This is V plus VO by V, and finally the frequency n prime, it is V plus velocity of car. Let us say the velocity of car is u, so V plus u by V minus u, and frequency is n, and just by putting 124 vibration, the velocity of sound is 330, velocity of car 72 km per hour, and it is 72 into 5 by 18, 20 meter per second, and it is 20 by 30 minus 20, and finally 124, it is 350 by, and 124 roughly it is 7 by 6, and I think it is 140 vibration per second. Next problem. In the given circuit, the current of the battery assumed diodes. Assume all the diodes are ideal. It is also taken from the deleted topic. Potential in this problem, potential, it is higher potential and lower potential given D2, D1, D3. Here D2 and D3 in forward bias. So it will allow the majority, it will allow the majority carriers to conduct, and D1 are in reverse bias. So diode 1 does not allow the majority carriers to conduct through it. So current, actually the circuit becomes, it is 5 ohm. Resistance of the ideal diode in forward condition is 0. So the resistance in this part is 5 ohm, and the resistance resistance 5 ohm, and the resistance it is 20 ohm, and the cell is 10 volt. Simple questions, you have to just find out the current through the battery, that is circuit current. Circuit current is equal to V by equivalent resistance, and equivalent resistance, it is very simple, 10 into 20 by 10 plus 20, and it is 200 by 30, and we can say 20 by 3 ohm. 10 volt given, it is 20 by 3, and finally it is 30 by 20, finally 1.5. ampere, and the right option is 3. Next problem. When potential difference applied across the electric elements, the current passing through each element given in the option, which is incorrect. This is not correct. We have to find out the incorrect. That is, the right statement is not the correct option. Wrong statement is the correct option here. And current and insulator, current through an insulator at 0 degree, at insulator 0 degree 0. Insulator means, you know, conductivity is infinity, conductivity is infinite, resistance is infinite, conductivity 0. So current, no current we get through the insulator, no question arises whatever may be the temperature. So it is the right statement but wrong answer. A semiconductor at 0K is 0 semiconductor at 0 degree 0K always behaves as an insulator. Behaves as an insulator. It is the right statement but not correct option. It is right statement but not correct option. Okay. क्योंकि answer is, question is which one is incorrect. So 2 is not the right option. A metal at 0K is finite. A metal at 0K is finite. Current through a metal at 0K is finite. Current metal have the any metal at 0 degree centigrade or whatever may be the temperature of the metal, that is conducting body, it has the particular certain finite resistance. So current through the conductor is always finite. It is also right statement but not the correct option. PN diode at 300K is finite when it is reverse. In reverse bias, diode does not allow the majority carrier to conduct or to cross the junction. So no current you can get. The current you can get due to minority carrier. So it is very small current and which can be neglected. In this case, I think they are considering the current due to the majority carrier. So 4 is the wrong statement but the right option. Next problem. Question number 41. A spherical black body with radius radius of 12 centimeter radiates 450 watt powers at 500 Kelvin. If the radius are half and temperature double, the power radiated to what would be? So it is also, the question is also taken from the deleted topic, and the power radiation by black body, power radiated by black body P equal to sigma A T to the power 4. Here T is the absolute temperature, and A is the surface area. Sigma is the Stefan constant. So P2 by P1 we can write is equal to R2 by R1 whole square into T2 by T1 to the power 4, and it is given 1 by 4 in the problem, and T by 2 it is 2 to the power 4, therefore it is 4. Power P2 is equal to 4 P1 and 4 into 450 watt, I mean 0018, and the right option here is 4. Next problem, let us see the question 42. Says the 3 rods each of length L and mass M are placed along XYZ axis in such a way that each of the rod is at its origin. The moment of inertia of the system. 3 rod, you know, let us say this rod is X and this rod is Y and this rod is Z, and it is the moment of inertia about the axis Z. So moment of inertia is equal to Ix plus Iy plus Iz. Since the system is rotating about the Z axis, since system rotating about Z axis, we can write Iz equal to 0, and the moment of inertia of the system is equal to 2Ix due to symmetry. Both the rod are same length and same mass, and rotating about the Z axis perpendicularly, so about it one end. So this is 2 ml square by 3, and finally the answer is 2/3 ml square, and the correct option here is 1. Next problem. A steel ball of mass 1 kg moving with velocity 1 meter per second, its de Broglie wavelength is equal to, it is also taken from the deleted topic, you know. So de Broglie wavelength associated with moving particle lambda is equal to h by p, and it is h by mv. Simple questions, just mass of the body is 1 and the velocity of body is also 1, so lambda is equal to h meter. The right option here is 1. Next problem. Work function of a substance is 4.0 eV, the longest wavelength of light that can cause photoelectric emission from the substance approximately. Work function, simple work function living. Work function, it is h nu. So minimum energy required to eject an electron from the metal surface, it is known as work function, and it is hc by lambda max. Here it is threshold frequency, you know, it is threshold frequency, that is minimum frequency, and minimum frequency corresponds to maximum wavelength, that is cutoff wavelength. The lambda max is the maximum wavelength up to which photoelectric effect can be taken place. And by simple, you know, if we put the value of Planck constant, the speed of light, and it is 12,400 by lambda in Armstrong, and it is energy in eV. So lambda 12,400 by energy in eV. It is very instrumental formula, you have to use in the examination hall. Don't put the value of Planck constant and the speed of light, it's become difficult to calculate. It is the formula. So lambda just max wavelength, lambda max is equal to 12,400, and the work function given is equal to 4. So this is 3100 Armstrongs, and this become 10 nanometer. Okay, so right option here is 3. Moving on the next problem. Under which of the following condition will convex mirror of focal length A produce an image that erect, diminished and virtual? It is also from the deleted topic. It's also taken from the deleted topics. You know, since the converging mirror nature is diverging. Nature of this mirror is diverging, and diverging mirror always produce virtual diminished image, whatever may be the object distance. Anywhere you can place the object from midpoint of the mirror to infinity, anywhere object can be placed, and the image is always virtual and diminished and formed with the midpoint and focus. Anywhere you can place object, and the image formed is always diminished. It is virtual diminished and erected. Correct option here is 4. Concept, based on the conception, no calculation is required here. Question number 46. A circular coil of radius 4 cm 20 turns, current 3 ampere, that splits in magnetic field of 0.5 Tesla. The magnetic dipole moment of the coil. Magnetic dipole moment. Magnetic dipole moment. Magnetic dipole moment. M is equal to NIA, NEA. Magnetic field 0.5 Tesla, it is not necessary in this case, it is just given, but you have to find out the magnetic moment, and here N equal to number of turns, I is the current, and A is the area. Okay, so magnetic moment, number of turns, first of all 20 turns, and current 3 ampere, and we have 20 turns, radius 4 centimeters, so area it is 3.14 into 4 centimeter, so 4 into 10 to the power minus 4 whole square. And by simple calculation, 3 into 3, 14, 16 into 10 to the power minus 8, and by calculation it approximately equal to 0.3 ampere meter. You just calculate it, and the right option here is 3. A thin double convex lens has a radius of curvature of each magnitude 40 cm and made of glass with refractive index 1.65. Its focal length nearly. A thin double convex lens. Radius of curvature each of magnitude 4 cm. So R1, R2 is equal to 40 cm. The focal length is equal to mu minus 1 is equal to thin double convex. The radius of curvature equals, so this is 2 by r, and finally this is 2 mu minus 1 by r. Focal length is equal to r by 2 mu minus 1. Radius of curvature it is given 40, and this is 2, 1.65 minus 1. Calculation going on, 2 into 0.65, and it is 40. .3, and it is 31 centimeter. Right option here is 31. Next problem. A body of mass 5 kg moving with momentum 10 kg meter per second, force is 2 Newton, acts on the direction in the motion by the body for 10 seconds. Increase in the kinetic energy you have to find out. First of all, momentum. Change in momentum, you know the force into time. From the Newton's second law, from Sir Isaac Newton's second law. So P2 minus P1 is equal to, force is given in this problem is 0.2 and the time given 10. So P2 is equal to P1 plus 2. P1 given, you know, 10 kg meter per second. So 10 plus 2, I mean 12 kg meter per second. So this is the final momentum of the body, and the, you know, change in kinetic energy equal to, we can write P2 square by 2m minus P1 square by 2m. This is the formula, you know, kinetic energy. We have the relation K is equal to P square by 2m. P is the momentum. This is the relation between the kinetic energy and momentum. Very basic formula, and it is 2 by m P2 square minus P1 square, and put the value 1 by 2 into 5, and P2 means 12 square. 12 square minus 10 square, so this is 44 by 10, and finally it is 4.4 joule, and the right option matches with 4. Next problem. Which of the following is not characteristic of turbulent flow? Not. Velocity more than the critical velocity, it is the characteristic of turbulent. So this is right statement but correct. Wrong answer. Velocity less than the critical velocity, velocity less than the critical velocity. It is the it is the wrong statement, but the correct option, the 2 is the correct option. 3, 4. Irregular flow, molecules crossing from one layer to another. So all 1, 2, 1, 3, 4, all are the correct statement for about the turbulent velocity, but correct statement are not the right option here, because we have to find out not the characteristics of turbulent flow. So next problem. 2 bulbs are fired simultaneously horizontal to in the different speed from the same place. Which blade will hit the ground first? 2 blade, let us say it is projected from a top of tower with different speed. It is different speed in the path of the horizontal speed. All horizontal speed remain unchanged. Horizontal speed remain unchanged. Horizontal speed remain unchanged. So whatever may be the horizontal velocity, the vertical displacement does not depend on the horizontal velocity, or horizontal velocity always remain unchanged, because G always acting perpendicular to the horizontal velocity. So the magnitude of the horizontal component remain unchanged, remain constant. So vertically down, it will both the particle moves vertically down at the same time, and it is H is equal to half G T square, and T is equal to root over 2H by G. So this question is based on the conception. You should have this conception that when the particle projected at different speed with the horizontal component, then the particle all the particles with the projected different velocities horizontally, so all the particles reach the ground at the same simultaneously at the same instant. Okay, but their ranges are different due to the different horizontal component of velocity. Okay, so both will reach the simultaneously, and 4 is the right option here. Next, let us see the problem. This is the last questions. Okay, that's all. Thank you for watching this video. Have a good day. Bye.